Hello everyone and welcome to our YouTube channel. I'm Sophia.
And I'm Kyle. Today, we have a very exciting topic for you all. We're going to explore the amazing world of data analysis using OpenAI ChatGPT Code Interpreter.
That's right. We're going to delve into how you can leverage ChatGPT to analyze data, derive insights, and make your data science journey easier and more fun.
We'll cover a wide range of topics, from descriptive statistics to complex machine learning techniques. But don't worry if some of these sound intimidating. We'll walk you through every step, making sure that you have a clear understanding.
Absolutely. And remember, data analysis isn't just for data scientists. With tools like ChatGPT, anyone with curiosity and determination can dive into data and uncover stories that numbers can tell.
So, whether you're a beginner who's just starting out, a business professional who wants to make more data-driven decisions, or an experienced data scientist looking to streamline your process, this video is for you.
So grab your coffee, get comfy, and let's dive into the exciting world of data analysis with ChatGPT. Alright, let's get started with our first example. Today, we're looking at the Titanic Dataset, which is available in Kaggle Dataset.
The Titanic Dataset is a very popular dataset among data enthusiasts. It contains passenger information like age, sex, class, and whether or not they survived.
That's right, Kyle. And today, we're going to compute some basic statistics like the mean, median, and mode. These are fundamental metrics that allow us to understand the data's central tendency.
First, we will download the Titanic Dataset CSV file from Kaggle. Then upload the file to ChatGPT. ChatGPT Code Interpreter allows you to upload your local data file to a Python interpreter environment for analysis. After the file is uploaded, ChatGPT will read the file and show some basic information about the dataset, including the columns, the first few rows of the data frame. Now, we can use the ChatGPT Code Interpreter to do data analysis.
We can say, show me the basic statistics of the numerical columns. This will provide basic statistical measures like count, mean, standard deviation, minimum, maximum, and quartiles for the numerical columns in the dataset. A table showing the aforementioned statistics for each numerical column.
We can say, show me the distribution of passenger ages. This will provide a histogram of the ages of passengers, helping us understand the age distribution of passengers on the Titanic.
We can say, show me the survival rate by passenger class. This analysis will give us an insight into whether the passenger class had an impact on survival rates. These numbers suggest that the class of a passenger significantly impacted their chances of survival, with higher class passengers having a higher survival rate.
We can say, show me the survival rate by gender. This analysis will help determine if gender played a role in the survival of passengers. These numbers suggest that gender significantly impacted the chances of survival, with females having a much higher survival rate than males. This is likely due to the Women and Children First policy.
We can say, show me the correlation between different numerical variables. This will help identify if there are any strong correlations between different numerical features in the dataset. The correlation coefficient ranges from -1 to 1. If the value is close to 1, it means that there is a strong positive correlation between the two variables. When it is close to -1, the variables have a strong negative correlation. There's a negative correlation, 0.338481, which indicates that the lower the class, 1SD is highest, 3RD is lowest, the lower the chances of survival. This aligns with our previous analysis. There's a positive correlation, 0.257307, which indicates that passengers who paid more for their tickets were more likely to survive.
We can also use ChatGPT to find missing values in the dataset. We can say, show me the missing values in each column. This will show us how many missing or null values exist in each column, which is important for data cleaning and preparation.
We can find the distribution of fares paid by passengers. We can say, show me the distribution of fares paid by passengers. This will help us understand the range and distribution of fares passengers paid to board the Titanic. The histogram above shows the distribution of fares paid by passengers on the Titanic. Most passengers paid fares less than 100. There is a long tail on the right, indicating that a small number of passengers paid significantly higher fares, up to around 500.
We use Titanic Dataset to learn some basic skills of ChatGPT Code Interpreter. Now let's look at Exploratory Data Analysis. We will use TIPS dataset from Kaggle. We can download the CSV file and upload to ChatGPT. The data contains information about restaurant tips. Each row corresponds to a separate meal at a restaurant for a party of people. The dataset records the tips-related information like total bill, tip, sex, smoker, day, time, size.
EDA is all about understanding the data's main characteristics, often using visual methods. We look for patterns, spot anomalies, test hypotheses, and check assumptions. Once the data is loaded, we can start uncovering the patterns. We can ask question, do smokers tip more than non-smokers? So, on average, smokers do tip slightly more than non-smokers according to this dataset. However, the difference is very small and may not be statistically significant.
We can also say, plot a pair plot of the tips dataset. The pair plot visualizes the relationships between each pair of numerical variables in the dataset, with the data points color-coded by whether the customer is a smoker or not. Remember that correlation does not imply causation, and these are just observations that might be influenced by other factors not included in the dataset. And with ChatGPT, conducting EDA becomes a straightforward and interactive process.
We can say, plot a heat map of the correlation matrix for the TIPS dataset. Correlation analysis helps us to understand how one variable changes in relation to another. It's a great tool to identify patterns and can help us make predictions. The heat map visualizes the correlation matrix of the numerical variables in the TIPS dataset. Once we have the correlation matrix, we can visualize it to make it more understandable. Heat maps are a great way to do this. They use color coding to represent different values, making it easy to understand complex matrices.
Next, we're delving into the world of time series analysis. This is an essential technique when we're dealing with data collected over time. Indeed, it's often used in forecasting, where we want to predict future values based on past data. Things like sales figures, weather forecasts, stock prices, and, in our case today, airline passenger numbers. For our example, we'll use the Air Passengers dataset. This dataset shows the monthly totals of international airline passengers from 1949 to 1960.
First, we upload the CSV file. It will display some basic information about the dataset. We can say plot the original time series, trend, seasonality, and residuals of the air passengers dataset. After decomposition, we can visualize these components to gain a better understanding of our data. Here are the plots for the original time series, trend, seasonality, and residuals of the air passengers dataset. As you can see from the plots, the number of passengers has an upward trend over the years, which means the airline business was growing during this period. Also, we can see a clear seasonality: passenger numbers rise and fall in a consistent pattern every year.
Exactly, Sophia. And the residuals, the part of the time series that the trend and seasonality components don't explain, seem quite random, which is a good thing. It means we've captured the main structure of the time series in our trend and seasonality components.
That's a great point, Kyle. And with Code Interpreter, conducting a time series analysis becomes a straightforward process. Next up, we're venturing into the realm of textual data analysis. This type of analysis is essential when dealing with any kind of text data. And in the age of information, text data is everywhere.
That's right, Sophia. Text data comes in many forms, from tweets and emails to news articles and books. Today, we're working with the SMS spam collection dataset, which is available on the UCI machine learning repository. This dataset includes thousands of SMS messages, each labeled as either ham, meaning legitimate, or spam. The goal is to build a model that can accurately classify new messages as either spam or ham. First, we download the dataset file. Then we upload the file to ChatGPT Code Interpreter.
We can visualize our data. A common visualization for text data is a word cloud, which shows the most common words in our data. We can say, generate a word cloud. This visualization can give us an initial understanding of the common themes in the messages. Here's the word cloud generated from the text messages in the dataset. The size of each word represents its frequency across all the messages. As we can see, common words like now, you, and will appear prominently.
We can also say, show a word cloud for spam and ham messages separately. As you've already seen, word clouds can be a useful way to get a quick sense of the most common words in a set of text data. Here are the separate word clouds for spam and ham messages. These word clouds provide insights into the different characteristics of spam and ham messages based on the frequency of word usage.
We can say, visualize the distribution of message lengths for spam and ham separately. This could help identify if spam and ham messages tend to have different lengths. The histogram above shows the distribution of message lengths for both spam, in red, and ham, in blue, messages. Most non-spam, ham, messages tend to be shorter, with a significant number of them being less than 100 characters long. Spam messages tend to be longer on average, with a peak around 150 characters.
We can also perform sentiment analysis by saying, perform sentiment analysis on the messages using TextBlob. Sentiment scores range from -1, most negative, to 1, most positive. A score of 0 typically indicates a neutral sentiment. It calculated the sentiment of each message using TextBlob and display the sentiment scores for the first few messages in the dataset. We can visualize the distribution of sentiment scores. The histogram above shows the distribution of sentiment scores for both spam, in red, and ham, in blue, messages.
As we continue our journey into data analysis with Chat, we now enter the realm of predictive modeling. In this segment, we're going to talk about regression analysis.
Exactly, Sophia. Regression analysis is a form of predictive modeling technique which investigates the relationship between a dependent and independent variable. It's used when the outcome or the variable we want to predict is a continuous value.
For this example, we're going to use the Boston Housing Dataset. This dataset contains information about various houses in Boston through different parameters. There are 506 samples and 13 feature variables in this dataset. The objective is to predict the value of prices of the house using the given features.
We first download the CSV file, then upload to the code interpreter. ChatGPT will show some basic information about the dataset.
We can say, load the Boston Housing Dataset and train a regression model. It will give the explanation of the steps of training a regression model. It includes pre-processing, train test, split, model selection, training, evaluation. There are missing values in some columns. There are various ways to handle missing values. A simple and commonly used method is to fill the missing values with the median of the respective columns. We will just use this method. Here are the progressing the Chat is making. Next, let's split the dataset into features and target variables, and then into a training set and a test set. For the train test split, a common practice is to allocate 80 of the data to the training set and 20 to the test set. The dataset has been successfully split into training and test sets. For simplicity, we'll start with a basic model like linear regression. Let's train this model on our training data. The linear regression model has been successfully trained on the training data. Next, let's evaluate the model's performance on the test data. We can use various metrics to measure the performance of a regression model.
Once our model is trained, we can make predictions and visualize the results. A scatter plot is a common way to compare our model's predictions with the actual values. We can say, predict house prices and plot a scatter plot of actual vs predicted values. A good model will have predictions closely following the actual values. Remember, no model is perfect, but with careful data analysis and tuning, we can get pretty close. This visual inspection aligns with our earlier quantitative evaluation, where we found an R2 score of 0.66 indicating that our model explains about 66% of the variability in house prices.
Well, we've come to the end of our journey today. We've seen how Code Interpreter can assist with various aspects of data analysis, from pre-processing and visualization to predictive modeling.
We hope this gives you a good understanding of the power of ChatGPT as a tool for data analysis. Whether you're a beginner just starting out or a seasoned data scientist, it can save you time and help you gain insights from your data.
We want to emphasize that the examples we covered today are just the tip of the iceberg. There are many more ways to use Code Interpreter in data analysis, and we encourage you to explore and experiment on your own.
Remember, the beauty of data analysis is in the discovery. So don't be afraid to ask questions, dig deep, and let the data tell its story.
If you found this video helpful, be sure to give it a thumbs up and subscribe to our channel. We'll continue to bring you more content on using AI and machine learning tools.
And don't forget to hit the bell icon so you'll be notified whenever we post a new video. We always love to hear from you, so please leave any questions or comments below.
Thanks for watching. Keep exploring, and we'll see you in our next video.